Hello and welcome, ladies and gentlemen, lovers of terminal, shell, and weird dark background. So today, as often, we will speak about Bash, and I wanted to show you a problem we had at work and how we solved it. And I think it's quite nice to know because I think this kind of stuff can happen to all of us, without exception, here and in the universe. So here's the context. I just recreated the problem we had with dummy files. So here I have a server which is called super server. It's just a binary compiled from this main.go file, and there is a script, script.sh. If we open the script, we see that at the beginning I run the server in the background because I have this ampersand here. And then the real script was doing a bunch of stuff, namely running a unit test and acceptance test. And for that, it needed the server to run. So that's the background of it. So if we run this script, what will happen? Oh, sorry. Forgot to kill something, and you will understand very quickly why. So if we run the script, what will happen? Well, the server is running here, and the script did its job and now it's over. The question is, did the server stop? If we do psa, we can list all the processes which are running right now. If I grep for super server, you can see here that the super server is still running. And it's not really cool because what I would like to do is running the script which runs the server in the background, and then when the script terminates, I want the server to terminate as well. Because this script was used in CI, and in CI, of course, you needed to terminate stuff. And even on your local, it's better that when you run a script, everything terminates. So what's happening here? Like with pstree, what we can do is having a more visual representation of processes, and namely process trees. Because when I run the script, the process of the script, which is in fact a subshell, because when you run a script this way, you create a child of the shell you are in, so a subshell, which is a child process of the shell you're in as well. So if I do pstree, and then I grep for the super server, oops, it's here, but I mean, we don't have that much context, so let's add some. Let's say maybe 5. So here you see that super server is a child of another process which looks very high up, but I mean, the bash script process itself is nowhere to be seen because it terminated already. So let's see. Let's make the script a bit longer by putting a sleep here for a lot of seconds. Let's kill the super server, and for doing that you can do our psa, and then you can do kill and the process ID, which is the first one here, this one. If I do kill the process ID, I can kill the process. So now if I do psa grep super server, there is no super server running, and what you see here, it's just the grep we pipe to ps, which appear in the running processes. So it's not the super server. So let's run our scripts, which now will won't terminate because we added this sleep at the end. And I need another, no, not this one, more this one, another pane in my tmux session. And now let's run our pstree again. Now it's more interesting because you can see here that super server is, when the script is running at least, the child of the subshell, which is bash. Because my current script right now, where I run the script is ZSH, so the current script I am in is ZSH. When I run the script, create a subshell, which is this bash process you can see here. So from here, to terminate this process, when the script terminates itself, I'm thinking, okay, I need to kill the whole process tree from bash to sleep and super server and whatever child there is inside. So I want to kill everything. To do that, and I need to kill again this super server process. So I have a way better way to handle kills with FZF, which is really cool. It comes for free if you install FZF, and if you link FZF with your shell. So it's way faster than that. Anyway, if I look at my script, what I want to do is killing my whole process tree. So to do that, I need to first execute something automatically when the process terminates. And for that, I can use trap. And if I do trap, a command, and then exit, it means that trap will get the signal sent by bash, exit, which is the signal sent automatically when the script terminates. And then when the signal is sent, it is trapped. And trap will run a last command before everything exiting. So what I want to do is kill the whole process tree. And to do that, there is another thing that the process ID, which every processes on a Linux or Unix system has a process ID, which is a unique identifier. And more than that, they as well have a process group ID, which is exactly the same for each processes of the same process tree. So it means that if I want to kill the whole process tree, I need to get this process group ID and to kill it. If I kill the process group ID, I will kill everything I want, including the super server. So, how to kill a process group ID? If I do kill here and some ID, I don't know this, it will just kill the process ID, the process with the process ID 54654. To kill the process group ID of ID 54654, I need to put a minus before. And this time, I will kill the whole process tree, which has a process group ID displayed on the screen. Now, how do I get this process group ID? Well, I mean, we can observe what's happening. So let's sleep again. A lot. I'm not sure I have still no. Then let's run the script again. Maybe on this side more. And let's look at this process group ID, at this process tree again. And now what I can do with pstree is if I add the option -p, it will display the process ID of every process. So if I do that, And yeah, what I will do is this. So here you can see that the process ID is different for each processes of the process tree, which is normal. Even better, what I can do, if I add -g for group, I can visualize the process group ID of every process. So if I do that, and it's again broken, so I will just close that. If I do that, you can see the first number here is a process ID. The second number is a process group ID. And you can see that for the first, for the parent of everything else, the process ID is equal for the process group ID. Okay? But for the children, they keep the process ID of the bash script, but they have their they keep the process group ID of the bash script, but they still have their own process ID. So basically, what I can do is taking the process ID of my script and say that it's a process group ID because they are exactly the same. And to do that, I can edit again my script. I can use my trap. I can do kill. Minus, because when you do minus without the minus before, like that, kill will think it's an option, but it's not what we want to do. What we want to do is killing a process group ID, and this is not an option. Because, you know, an option like -p, for example, or whatever. So if we put minus before, it says to kill, okay, after those minus, there is no options, so don't consider that as options. It solves some ambiguity. And you can do that with any CLI you want, actually. I mean, any CLI, I'm not sure, but I mean, every CLI I tried, it works. So, now, how to get the process ID of the script, of the subshell? Well, we can use the special variable $, and we will use a single quote here, otherwise we can have problems. And if we do $, it will do minus current process ID, and then, since process group ID is equal to process ID, it will kill the whole tree. So let's try. I'm not sure if the super server is still running, so let's kill it. Now let's run the script. Oh, there is a problem. Oh yeah, I forgot to precise what signal it should trap to run the command. Let's not sleep anymore. Let's kill the super server. And let's run the script again. So, question, did it work? Is the super server still running? Well, you can do psa, gripping the super server, and apparently it works. So if I do script again, I can do it again and again. Oh, yeah. And it works, because each time I run the script, the server is killed, I can rerun the script without any problem because the server is not running. And if the server was already running, there would be a port conflict, so it would crash. So it looks like it works. That's really good. Now, it's not the end, because the real problem we had is that script was running into another script. So let's call it parent script. Always put the good shebang. now we were running the script like that. And we were calling the parent script. So to understand what's happening now, let's sleep again. Both for the parent script and the script. And let's run the parent script. Oh, I need to change the permission before doing so. Okay, let's run the parent script. Oh, the super server was somehow still running. Okay, so let's run the parent script. And now let's look at pstree to understand a bit what's happening there. Yeah. So again, we need to adjust a bit that. Oops. Oh my. Okay. Let's just do that. So, because I never really mentioned my my pain in tmux, that's crazy. So here now we have two bash process. The first one, which is the parent script. The second one, which is the script. And then we have the children, which are the sleep and the super server. The problem now is how to kill the whole process tree from the child here. That is script.sh. You could tell me, well, just put the trap on the parent script. But we are not allowed to do that. Why? Because in the real world scenario, this parent script had a lot of other functions which was running other scripts, and the trap wasn't relevant in these cases. So if we would have put the trap in the parent script, it would have caused weird stuff in other function we could have called on it. So it wasn't an option to put the trap on the parent script. But the parent script has the ID, which is equal to the process group ID. So how to get from a child the process group ID of the whole process tree? That's the question. Let's kill that. Let's kill the super server. So we have two options for doing that. The first one is to use ps, and if you do ps minus p and you give a process, so let's say, let's run the that, and as you can see, the trap can't kill the process group ID because the process group ID 103298 doesn't exist, which is normal because we try to get the ID of the child as process group ID, but the ID of the parent is equal to the process group ID, not the ID of the child. So to do that, we can we have two solutions, as I was saying. The first one is to use ps, and if you do, so let's do ps a first. To grab the super server, and the super server is running on the with the process ID 103299. Okay, if you do ps minus p 103299, you will get the process which runs with this ID. Great. If you do minus o and then pgid, you will get the process group ID of the process of ID 103299. Now, it's perfect because we can call that in our trap to get the good process group ID and kill the whole tree. Now there is a problem though, because there is this pgid header we don't want. So for that we have two solutions. Either way we add a weird equal sign at the end of pgid, and then we have only the process ID. Or we can add, I think it's only GNU, but I'm not sure. If you have a BSD version of PS, it might not work. No headers, and it does exactly the same. The advantage is it's, well, more explicit. So let's take that, and let's open our script. And instead of killing this $, we would add that. And then we would replace this group ID by $. So what it does is, again, it just outputs the pgid of the current process. And it kills it. I mean, it kills the process group ID, which is the whole tree. So will it work? That's the question. I think I need to modify parent script as well because it has some sleep. Yep. So let's try to run the parent script. Oh, I need to kill the super server before. Again, let's try to run the parent script. And there is big problem in my script. Oh yeah, I forgot the $, here. And I think that's it. Let's try again. Let's kill the super server. The super server is not really super. It's a server, but it's quite annoying. So let's run the parent script. Bad substitution. What's happening in there? Oh yeah. I need to do that. It will be better. Let's kill the super server. Let's run the parent script. Argument must be processor group ID. I have many problems here. What's the problem? Oh, yeah, I see the problem. Because if you recall, it was here when I display the process group ID, there is a space at the beginning. And you can't put a space between the minus and the process group ID in my script. So we need to delete it. So let's open the script again. And let's use tr for that. Minus t. And then we want to delete a space. So we can do that. All right. So now it should work. Let's run the parent script. Oh my god, it gets worse and worse. Unexpected EOF. What? What's happening here? Oh yeah, forgot the quote. Sorry for that. It's always when you demonstrate some things, you have so many problems you didn't have before when you were rehearsing. Let's run the parent script. And this time it works. You see the last line, zsh terminated parent script.sh. If we try to find the, oops, that's not what I wanted to do. If we try to find the super server doing PSA, it's not there anymore because it worked. So that's one solution. Another, maybe more simple solution, I mean, not sure if it's simpler, but it works as well, is to keep this, but to replace the process script the process parent script.sh by the process script.sh. So let's visualize it again by doing a lot of sleep. Okay. If I run the parent script right now, and if I look again as pstree, the idea here would be to replace the parent script process, this one, by the child process, script.sh, this one. And if we replace the process, the script.sh process, this one, would get the process ID of the process replaced. And in that case, since it has the process ID of the process replaced, the process ID becomes equal to the process group ID. And to replace a process like that, you can do in the parent script exec. And in that case, the parent script process will be replaced by the script process. And because of that, in the script process, I can just again kill the process ID because the process ID will be equal to the process group ID. Oops, forgot to delete the sleep. Here we go. So let's try. Let's kill the super server before, as always. Let's run the parent script. And let's see if the super server is still here. And it's not. To be sure, we can do a PSA, grabbing the super server. And the super server is not anymore. So it worked. So thanks a lot for watching. That's the end of the video. I hope you liked it. I hope you learned something about processes in Linux and how to manage them, to kill them if you want to kill them. Another thing though, I wanted to mention is you can capture more than the exit signal. Let's say that our script is running for quite some time and it's possible that a user do a Control-C on the script. It means that the script didn't really terminate, but we sent an interrupt signal to the script to terminate it, which is different. For that, you would need to use the signal SIGINT for signal interrupt. And let's imagine the script as an error. Like for example, the script runs the server, do a bunch of stuff, and terminate with an error. Again, it's not the signal exit, which is send. It's not just signal SIGINT, but the signal R for error. Makes sense. So, like that, we are really sure that our script will always kill our super server and whatever we are running in there, actually, whatever super server can call a subprocess of subprocess of subprocess, because we call we kill the whole process tree. Again, thanks a lot for watching, and I wish you a great rest of your day.